Now, student, today we are going to discuss the neural network representation. In our daily day-to-day life, there are many situations in which we need the support of the machines. For example, in case of the image recognitions and in case of the voice recognition and like the share market prediction, as we all have expert in this field and we can easily match a certain photograph with a certain person's or a voice with a person and can predict the values, but we need an expert can do this things over a certain number of uh, fixed number of data or for certain number of times. But if we use the knowledge of the expert and design the system in such a way that the machine get the knowledge of the expert and is efficient to think or analyze the situation in the way the expert does, then we can get a very better results. Keeping in the mind the same thing, for example, the CCTV installed in different cities, which can recognize a criminal found in some area and can give the alert message to the police stations. Similarly, the voice of different person can be analyzed via machine and the intended person can be identified through their voice over the telephone channels or mobile channels. In the similar way, an expert in a share market field can analyze a company or one company or more than one company, like three or four companies in a single day. But he cannot analyze all the companies enrolled in the stock exchange in the similar way and with the same efficiency, because human will have a tendency that they feel lethargic after doing job for 3 or 4 hours and they become error proofs. In that situations, to analyze the large number of problems or scalarize for the scalability of the problems solution, we need the support of the machine. So we design a machine with the help of the experts in that field. That is done, and the most simple form and the design of this machine is shown in this diagram. Here in this diagram, there is a circle that is called the perceptrons, and it is having three inputs x1, x2, and up to xn with their weight w1, w2, and wn respectively. Here there are three inputs and there is a one output function, like in a situation where we analyze a person that should we trust him or not depends on the many factors. For example, for deciding to make a person our friend, we decides a person on or judge a person on different criteria. Like we check out that what are the educational qualification of that person's or IQ. Second, the personality of the person, and third, the characteristic traits of that person, like this. And different person give different weightage to the different factors. So there is no unique neural network design for a particular problem, but different expert design different models. Similarly, in this case, and initially they don't know the exact weight of their inputs. So initially, what they do, they design a perceptron and identify the possible inputs and assign them some probable weight. And here, the weight are assigned in such a way that the total sum of the weight becomes equals to 1 on a single perceptron. Here, there is an output fx, and output is not necessarily 0 or 1 like in normal machines, but it can be a real value also. It is actually the aggregate sum of the all the inputs, like x1 into w1 plus x2 into w2 and plus so on xn into wn. And the final output could be the 0 or 1 or uh, or some real values. Here in this diagram, it is the most simple diagram, but in real world, the situation becomes very complex. In here, we need a series of perceptron and a layer of perceptron to handle the complex problems. Here, in the next diagram, we can see there is an input layer and there is an output layer. Input layer is the layer through which the user particularly provides or give its input, and output is the layer through which the user gets the output. It's like a black box, but between there may be layers of the perceptron which are called the hidden layers. Its number of hidden layers depends upon the complexity of the problems. So, in summarize, we can say that there are a series of the perceptron and the layer of perceptron between the inputs and outputs. This is the basic models of the artificial neural network. For designing a neural network, we must have to follow the following 8 steps. The first step among this is the data collection. Before starting or scratching any problem, first we need that is the data that we want to judge or take a decision on it. They are initially the testing data and the training data are collected, and they are not differentiated, but we just focus on collecting the data. In the step 2, we divide the data into the two sets, the training data sets and testing data set. The training data set is the data for which we know the final solutions. That what are they? For example, for image in the scenario of image recognition, we particularly have collected 10 images, and we actually can identify whether whose image are these. In this situation, we divide the data into training data and the testing data. Training data are the data about which we already know, and testing data are the data which we want to predict or take decisions. There are generally 80% of data are collected as a random training data before designing a neural network, and 10% of testing data and 10% for the secondary testing. In step 3, the expert of the field design their respective neural network with different layer of the perceptrons and different number of inputs. This varies from the expert to expert, and they design it according to their knowledge. And after completing their design process, the next step they follow is the initialization of the weight and parameter tuning. In weight initialization, they assign a certain weight to different input variable, and this is done by their experience and knowledge, and but they are not sure about, and they verify it by checking that whether the data model work correctly over the training data. For example, if there are 10 images which we know that what actually they are, then we check out the model, then on the initialized weight whether they identify the image or not. And if they do not identify, then we do it we modify the weight, and we do it iteratively until unless we get the desired results. So at this weight is initialized and weight is modified and again modified till we do not get the final desired result. Once the data get verified for the training data, then we move to the step number 5. After in this step 5, we transform the data. In transformation of data, we we transform the data into the format or number of inputs which the data model expects. So here we transform the actual input data into the factors or components which the neural network design model asks for. In the next step is training data set. As I have told you, the design model and transformed data are applied over the network, and if we do not get the output, we adjust the weight until the computed output are within the acceptable tolerance of the known output for the input cases. So once we are able to properly identify the training data, then we move to the next step 7 and repeat the same process for the testing data. Uh, this is like black box testing. Here we check out that the model is working properly with the testing data or not. If it does not work accordingly, then we move back to the step 6 and repeat the weight evaluation and weight modification steps. So, and step 6 is after repeating and modifying the weight at the step 6, we move back to the step 7. Once the model verified for the testing data, then it is finalized, and in step 8 it is implemented for the practical use. In this way, the network can be, we have designed the neural network data, and used this is used for taking the proper decision. So this is the utility, and we know that uh, we know that this neural network is very efficient in taking the decision.